Hello, and welcome to this Berg webinar. Now I would like to introduce today's presenter, Bill Hubiak. Bill is the Director of Product Engineering and Innovation for the Rexnord Specialty Components Group. Bill, welcome to today's event, and with that, I'm going to pass things along to you to get us started. Bill, go right ahead.
Hello. Today we'll be talking about when a belt drive is better for mechanical power transmission than some of the other options that exist in the industry. Hello, I'm Bill Hubiak, Director of Product Engineering and Innovation for the Rexnord Specialty Components Group. I'm responsible for the product lifecycle of 3 brands, including WM Berg. I've been with the company now for over 20 years. I have experience in research and development, engineering management, and product management. Here's an overview of what we'll be talking about today. We will start off with the drive design considerations. What questions should be asked up front to help decide the appropriate solution for your application? Next, we'll review some of the common drive designs. We will examine many of the different design types and alternative solutions offered by Berg. We will also discuss a couple of real-world examples and how we used Berg product to solve some of the problems. Finally, we'll discuss the belt system design. When a belt drive is the correct solution, how do we go about the calculations to ensure the system will meet the customer's needs? When looking at what to consider when designing a drive system, here are some of the items that we at Berg examine. First, we review the total cost of ownership for the customer. How critical is this drive to the customer's application? How often do they expect to do maintenance on the system? What is the expected life of the product the drive is going into? How easy will it be to perform maintenance once the product is fully assembled? Once we understand this, we move on to the performance aspects, defining the precision and accuracy required for the system, how fast both the input and output of the drive are expected to be, and what noise and/or vibration considerations there need to be for the end product. This is very important to define up front. Sound can be transmitted in many different ways, and it is easier to design this out from the start versus determining a system is too loud at the end. Space considerations are examined next, looking specifically for the envelope size, any weight restrictions, and any other factors that may influence the space in which the drive will go. Special consideration is given to the locations of fasteners not only for the drive system, but also for any components that will be hidden once it is installed. Environmental concerns are next considered, defining the temperature and other factors that may influence the design. These factors will be critical in determining the enclosure type that will be needed for the drive. It will also limit what materials can be used throughout the system. Reliability and service further define the aspects from the total cost of ownership. It is the customer's expectation that the drive will make it 1 year beyond the warranty period, or do they have a brand reputation to uphold that is significantly different than this? What is their expected level of quality? As you can see, many of these factors go hand in hand with other design aspects already considered. Last, we consider the installation process. Have we thought about when the drive will need to be installed? What tools will be needed to install this? Are there any special skills required? Now that we have gathered the information needed to select a drive design, what general solutions do we look at? The next slides are a review of many of the more common drive solutions, as well as some of the Berg alternatives to help solve problems. The first option we will examine is roller chain. As many of you know, this option has been around for many years and is well proven, provided it is properly maintained. Roller chains are ideal for applications with high reduction ratios and high load capacities and are nearly as efficient as a gear drive. They also tend to be resistant to environmental effects, as they are unaffected by sun, heat, moisture, and oil, and can also be made from corrosion-resistant materials. Some concerns with roller chains are that they can be noisy, especially when not tensioned correctly. When used in higher speeds, a constant lubrication source needs to be present, as the change in direction around the sprocket can fling the lubrication away from the rolling elements of the chain, resulting in sliding wear. Also, roller chains can be sensitive to alignment of the sprockets. Care must be taken to ensure that these are within the chain manufacturer's allowance for optimum life and performance of the drive. Berg has designed a number of drop-in roller chain replacement materials under the FlexiPitch product line to address some of these concerns. These are directly interchangeable with the corresponding roller chain. No need to change the sprockets in the system. The polyurethane overmolded material helps to provide a quieter system while reducing the inertia due to the weight of the chain. This material also eliminates the need for lubrication. There are no moving joints with the FlexiPitch roller chain alternative to need oil. This system is best used in applications where the tensile load with the chain is less than 75 pounds. The entire product line offers many different sizes and load capabilities. We will be happy to select the appropriate model for your application. It is possible, using this system, to design for no backlash without the requirement for special sprockets or other difficult considerations. Next are gear drives, what we consider to be the most torque-dense option for drive systems. That is, the ability to transmit the most torque for the given space of the drive system. Most of this was covered in our previous webinar, but some things to consider when looking at the gear design include the gear type, for example, spurs, helicals, bevels, or worms. Be sure to understand the advantages of each and what is right for the drive. Next is the tooth strength. When doing so, please consider both running and any shock loads that might be put into the system. Third are the sizing of the gears and any materials that are being used. Typically, as size decreases, the material requirements will increase. Next would be the rating system and any safety factors. How much safety factor do you truly need to meet the design goals? And finally, any of the backlash requirements. Please be sure to be realistic here. Decreasing backlash can greatly increase cost. Gears have some drawbacks, including lubrication and noise, especially as the speed, both input and output, increases. Berg has a number of options to help directly counter some of the issues with gear drives. Our FlexiGear line of belts is designed to work with spur gears. These belts can handle operating loads of up to 25 pounds with a maximum speed of about 375 feet per minute. Because the gear teeth are not interfacing with one another, these are virtually silent running. These belts are a great choice when spacing is an issue, but torque multiplication is not needed. We have seen several cases where customers are using 5, 6, or even as many as 10 gears to provide spacing around a feature, but there was no multiplication of torque or speed. This significantly increased the amount of backlash in the system, whereas using the belts, this could have been eliminated and would have been easier to assemble and maintain. Timing belts. If you are a car person, you are likely familiar with these for controlling the camshaft timing relative to the crankshaft. These have high accuracy, good torque carrying capability, and are generally quiet running. They do not require lubrication. This is a big plus when designing the system because for fast-moving systems in small areas, it can be difficult to add an oil pump for chains and gears. However, these are also susceptible to the application environment. Heat, chemicals, and oils can cause the rapid breakdown of the material. Berg offers a line of timing belts called FlexiGrip that are designed as a substitute for a traditional timing belt. These belts have a stainless steel core that give high strength and low stretch. One key feature of these is that they are specially designed to not need flanges on the sides of the pulleys. The center rib of the belt with the pulleys will ensure that these track straight and have low wear. This is very helpful should the belt need to be replaced in the field. It can be very difficult to get the old belt over these flanges. Another timing belt alternative we offer is the MiniPitch line of belts. This is a specially designed line of belts that has a circular pitch based on pi, making it easier to have the right number of pitches for the application and having lower requirements for tensioning. Also, because of the center rib design of this belt, it is possible to twist them such that power can be transmitted 90 degrees to the driven shaft. If you have owned a car, you are likely already familiar with V-belts. These are popular choices for lower torque, higher speed applications and have the advantage that, if the torque gets too high, the belt can slip. For example, the characteristic squealing noise emitted from under the hood when the air conditioning clutch freezes. V-belts have very little backlash because the belt is in constant contact with the pulley. Additionally, with no teeth, there is very little wear of the belt system. While these require little maintenance, these do need to be periodically replaced due to the heat generated within the belt from the speed and flexing, causing degradation of the belt. Also, any oil can be absorbed by the belt, significantly decreasing the torque capability. As you might expect, Berg offers a line of V-belt substitutes called PowerV. These belts are specially molded in segments to allow for greater flexibility and increased misalignment capability of the shivs. PowerV is also made from a special polymeric material that is highly resistant to abrasive wear and is more tolerant of dusty environments. As with most of our belts, these can be spliced to almost any length, allowing the user to keep a spool of material on hand and make to any length needed for the application. Our GBF series of FlexiBelts was designed as a problem solver for when it was not possible to get proper alignment between the sprockets in the system. This belt allows for up to 7 degrees of misalignment between the sprockets without loss of motion and is capable of a 90-degree offset of the input and output shafts. The center rib design of the belt, reinforced by either stainless steel or Kevlar, allows for high flexibility and strength. This belt is also ideal for replacing low reduction ratio gearboxes, especially where the center distance between the shafts is too great to make bevel or helical gears an option. Berg offers a line of belts that can take the place of other belts, chains, and even gears. These are offered with either a stainless steel or Kevlar backbone, giving high strength as well as high flexibility. The engineered polymer material is designed to give trouble-free service with resistance to wear, chemicals, and corrosion. Additionally, they require no lubrication and very little maintenance in the correct applications. Our engineers are always willing to help you choose the correct belt for your application. Please feel free to contact us with any of your questions and selection of these belts. Now let's review a couple of examples of how the Berg series of belts help to solve a problem for our customers. The first is a military application, where they were using a chain and sprockets to control position of a small antenna for a mobile communication system. This was on the exterior of the vehicle and not sealed to protect it from the environment. All types of dust and weather were able to get into the drive. The existing solution used a steel chain that was lubricated with common engine oil, applied occasionally from an oil can. This was selected because of the availability when deployed. The detergents in the oil suspended the sand and dust, creating a sludge that would render the communication system nearly useless. The manufacturer of the antenna system approached us to find a solution to the problem. We selected our FlexiPitch belt to replace the chain and use their existing sprockets. This enabled the system to run without lubrication and, because of the polymeric nature of the chain, without concern for the contaminants in the environment. Because we were able to use their existing sprockets, it was very easy for the end user to replace the chain in the field and have a functional system. Another interesting application was for the aerospace industry, specifically for business jets. Many of these have cellular shades between the actual window and a protective piece of plexiglass on the interior, protecting them from dust and dirt. The customer was looking for a method to easily open and close the blinds that would be consistent with the level of quality the end customer would desire. We combined our linear components with our Flexibelts to create a system that, as a passenger slid a lever from one side to the other, the shade would smoothly open and close. The belt provided a low-profile means to transmit the power up to the mechanism that controlled the shade position while meeting noise and cost targets. The design was later revised to use an electric motor to open and close the shade by simply removing the lever and coupling the electric motor to the lead screw. As a summary of what we have discussed, here is a table highlighting the features of each of the drive types we reviewed. As you can see, for many applications, the Berg line of molded belts can meet your needs better than some of the other systems. The engineered polymeric material was specially designed to resist many common environmental conditions, eliminate noise, and eliminate the need for lubrication. Additionally, The belts were designed with flexibility in mind, giving the designer many more options when using in an application. Please keep this table in mind as you evaluate your drive system designs and review alternatives. Alright, now that we have covered the different drive applications and a belt system has been selected, let's go over the process to design the system for both strength and long life. There are many steps to consider and, in general, a logical progression to these steps, starting with the power and working our way through to belt tensioning. The first step in designing a belt drive system is to compute the design power of the system. The required power is based on the speed and torque required to affect the desired outcome from the system. This result is then multiplied by the safety factor to determine the design power. Next, the force in the belt is determined based on the planned sheave and sprocket size. This will be a calculation from the transmitted torque and the pitch diameter. Be sure to follow manufacturer recommendations for belt strength. If the force from the system exceeds the strength of the belt, either larger diameter sprockets could be used, if there is room, or a different system will need to be chosen. If the target belt force is known, the sprocket size can be calculated directly using the input torque to the drive. It is important to do these calculations prior to the design effort. It will be more difficult to fit a drive system into an existing design than to design around an appropriately selected system. The second step in designing a belt system is to examine the speed of the sheaves and belt. It is important to ensure that the maximum linear speed of the belt does not exceed the manufacturer's recommendations. In the case of Berg molded belts, this is about 375 feet per minute. To do this, first the velocity ratio is determined. This is calculated simply by dividing the input rotational speed by the output rotational speed. Then, using this and the design speed for the selected belt, the sprocket size from the previous step can be checked to ensure that, despite the design being strong enough for torque, the linear belt speed is not exceeded. Once this is known, it is possible to calculate the horsepower of the system to ensure that the drive input is adequately selected. If the input rotational speed is lower than typical motor speeds, an additional reduction could be used to achieve the desired goals. In many cases, a belt system is designed to drive more than one output. For example, in an automotive application, the serpentine belt can drive the power steering pump, the air conditioning compressor, the alternator, and, in some cases, the water pump. While the path of this belt may seem tortuous when trying to replace it, careful consideration was given to ensure that the required belt contact was made to transfer the torque needed to run the accessory at the appropriate speed. With the Berg line of belts, it is possible to do this same thing, have the belt drive multiple components. However, special care needs to be taken to ensure long life operation of the system. For our belts reinforced with aramid fiber, it is possible to connect the accessory such that reverse bending of the belt occurs. This can give a lot of design flexibility when multiple outputs are needed. When designing for multiple outputs, please be sure to follow manufacturer's recommendations for sprocket engagement with the belt. Not doing so can result in premature failure of the sprocket and/or belt. Speaking of sprocket engagement, our recommendation is that the minimum engagement with the belt is 5 teeth at any time. This ensures that there is adequate distribution of the force over the teeth to prevent exceeding the strength capacity of the sprocket. Now that the pulleys have been selected, it is time to start the design of the process. With the Berg system of belts, there are some additional design freedoms that you can use to increase the tolerances available to the manufacturing team, thereby helping to control costs. If you are using a Berg molded belt that contains a single load-carrying member down the center, it is possible to have up to 7 degrees of misalignment between the sprockets. It may also be possible to rotate the output 90 degrees relative to the input shaft, provided there is enough room to properly guide the belt. For Berg belts that contain 2 or more load-carrying members, for example, a ladder-style construction, these are designed for a maximum of 1/2 degree misalignment between the sprockets. Exceeding this will have a significant impact on the life of the drive system. It is possible to use the belt system to reverse the relative directions of the input and output shafts. The advantage of doing this over using gears is that there will be virtually no backlash in the system due to the extended contact area of the belt with the sprocket. Because of this, the output rotational position can be very closely held relative to the input position in cases where this is important. However, using the belts in a direction reversing manner will require additional guides to ensure proper operation and will likely shorten the life of the belt system. Areas to monitor include the wear of both the sprocket and drive pins of the belt system. This can be avoided by making the transition as smooth as possible. Abrupt changes will cause rapid failure of the belt. Now it is time to determine the length of the belt that is needed for the designed application. For inline sprockets, the calculation on the left side of this slide can be used. Please note that the pitch diameter of the sprockets should be used except when using a V or O-ring belts. Then use the pulley OD for the calculation. Our website, www.wmberg.com, also has a calculator that you can download to help you with this. Because most Berg belts are segmented, the number of pitches will need to be calculated to determine what to order. This is done simply by dividing the length of the belt by the circular pitch of the chosen belt. There cannot be any fractions here. Please round up to the next pitch for the proper belt size. Proper tensioning of the belt system is very important to ensure transmission of torque and long life of the drive. This can be accomplished in a multitude of ways. First, as shown in this slide, a chain tensioner with idler can be designed into the system. Keeping in mind our discussion earlier about reverse bending, this is typically installed inside of the belt and spring-loaded, though there are cases where the idler is simply installed in a slot and manually adjusted for wear. Another method for belt tensioning is to allow one of the sprocket shafts to float inside a slot and use a spring to apply a force to that shaft. This can be useful when space constraints prohibit other methods of tensioning. Many people have rules of thumb that they use to determine chain tension in their applications. The proper method is to measure the amount of deflection based on the center distance of the shafts for a given force. In the case of Berg belts, we recommend 1/64 of an inch of belt deflection per inch of center distance when a force equal to 5% of the ultimate belt load is applied normal to belt. I would like to take this opportunity to thank you for attending today's webinar on belt drives and when they are the appropriate choice for mechanical power transmission. As I've reviewed, there are many cases where belts offer the best performance characteristics and best value as a drive system. Additionally, Berg has many different belt options that can help you solve many of the challenges commonly found in belt drive systems. We are always more than happy to help. Please feel free to use our website at www.wmberg.com to contact us and find out how we can help you to solve your problem.
Okay, Bill, thank you so much for that great presentation. Here's your first question. What are the typical allowable temperature ranges and operating speeds for belts?
For belts, the allowable temperature range and speeds will be driven primarily by the materials used to construct the belts. For our line of molded belts, this temperature range is -15 degrees Fahrenheit to 180 degrees Fahrenheit, and for speeds up to about 375 linear feet per minute. It's important to note that there is a minimum temperature for belts, as below this, the polymeric material will become too stiff to transmit torque, either starting to see slipping or possibly even some skipping of teeth. Other belts have different temperature and speed capabilities. Please be sure to review the manufacturer's recommendations to ensure that they meet the needs of your application.
Okay, Bill, thanks for that answer. Here's another question for you. Why are pulleys of lower tooth counts designated to be used as an idler only?
As we discussed earlier in the webinar, there's a target amount of engagement that the belt needs to have in order to properly transmit torque and stay safely below the strength limitation of the sprocket. For Berg belts, this target is about 5 teeth. With the lower tooth count pulleys, achieving this may result in wrapping the belt too far around to allow effective torque transmission. For example, if you wrap a belt around a 8-tooth count sprocket and you're trying to get the 5-tooth engagement, you'll end up with a crossed output. As such, we generally recommend the lower tooth count pulleys for non-power transmitting applications, such as idlers to guide the belt and tensioners.
Okay, Bill, here's another question. What are the benefits of using a fiber strand instead of a stainless steel wire?
The stainless steel wire that we use in our line of belts provides a good, strong background. However, it can be a bit stiffer and limit the amount of flexibility in certain applications. By using an aramid fiber reinforcement, flexibility is greatly increased without sacrificing strength in the belt. As we also talked about earlier, using the aramid fiber can permit reverse bending, giving greater flexibility in the drive design for your application.
Thanks for that answer, Bill. Here's another question. Why is it so important to tension the belts? What can happen if it is not?
Belt tension serves many purposes in the system. The first of which is to ensure that the torque is properly transmitted. Many belts require the proper frictional force between it and the sheave to transmit the torque in the system that the whole thing was designed for. This can result in the belt slipping, similar to the V-belt slipping and squealing in an automotive application. Additionally, with the Berg line of belts, if proper tension is not maintained, it is possible for it to jump a tooth and lose timing between the input and output shafts. If the system is reliant upon this timing, bad things can happen in a hurry.
Okay, Bill, this is going to be our last question today. Does the material of the pulleys and sprockets matter in terms of strength in the system, or will the belt always be the limiting factor?
The belt is not always the limiting factor. The material of the pulleys absolutely matters, and in several different ways. The obvious is in the strength of the material, in the sprocket material. Making sure that the tooth strength is high enough to withstand the force from the torque of the system, and that the interface with the drive shaft will be sufficient. Another way that the sprocket material matters is in the environmental compatibility of the system, both for temperature and corrosion resistance. One thing you want to make sure is that the sprocket has adequate corrosion resistance, so that through the life of the system, it doesn't generate corrosion products on the sprocket teeth that could be abrasive to the belt and actually cause the belt to wear out sooner than the expected life of the system. That is all the time we have for questions today. Please complete the post-webinar survey and use our website to contact us with any power transmission related questions that you might have. Thank you.
All right, Bill, thank you. We are going to wrap things up. Bill Hubiak, thank you so much for taking some time to be here with all of us today. And thank you to all of our audience members for being part of this webinar event. Take care, and we'll talk with you soon.